Okay, for this problem, we're going to use the binomial expansion. So that's here. It's written in two different ways. This just means that the order of the x and the y doesn't matter. They could be switched. These two things are basically the same. Okay, so what we could do is just write out the entire expansion of this binomial, and we would have 7 terms. But we'd like to find a better way, a shortcut, because imagine if you had here a number like 20 or 100. You wouldn't want to write out all those terms. So it turns out there's a shortcut here. And the idea is that we don't need all of these terms. There's only one specific one that we need because we're looking for basically the coefficient in front of the x squared term. All right. So the x squared term, I'm going to use just the sort of general term. Okay. So we got x to the power k, and y now is 2 over x. That's not plus, it's times. So we got 2 over x. Ooh, mistakes. Mistakes happen, don't they? Okay, so we need to think about when will this make an x squared? Well, it'll make an x squared when k is 2 more. So when this is 2 more than this. Okay, so they're going to add up to 6, and so it looks like if k is 4, then n minus k. So it's kind of, I'm just using trial and error because the numbers are pretty simple. N minus k is going to be 2. N is 6. Okay, n is 6. And so the x to the k term needs to be 2 bigger than this because the x is in the denominator. Okay, so when we write this out, it'll be even more clear, I hope. So let's go ahead. So n choose k, that's n choose 4. And then we have x to the power k. And then we have 2 over x to the power 2. So this will make an x to the power 4 in the numerator and an x to the power 2 in the denominator, giving us what we want, which is x squared. And that's the only term that's going to make x squared. So that's why we only have to make one term. Okay. Now it would be a good practice for you to write out the entire thing like this, and then it'll be clear why it is that one term that you need. All right, so let's, this is 6 factorial, 4 factorial, 2 factorial, x power 4, and we've got 2 squared, x squared, and you can see now these cancel and leave us an x squared. So that's what we want. And now all we care about is the coefficient. So let's put the coefficient over here. I'll change the color. Okay, the coefficient is, let's see. Let me do this a little quickly. 5. Okay, you should double check this. 5 times 6 times 4. Oh. So that's this stuff. Okay, I canceled out the 4 factorial. So I'm left with 5, 6, then the 4. And then the 2 here. And then we got a 2 there, and we've got 60. Okay. Double check that arithmetic, but the method is what's important here. And the important thing really is to So I recommend you do the entire expansion and then recognize why it is that you only need that one term.